Hey everyone, welcome back to the lab. In this video, we're going to be talking about 5 reasons F# is a great Python alternative for scripting, side projects, and enterprise applications. So F# and Python are similar in many ways. They're both minimal languages that excel at getting things done quickly with minimal boilerplate and mental overhead. However, Python often struggles at scale due to its lack of native type safety and caps on possible performance. F#'s unique design solves for these gaps, allowing you to build programs in the same lightweight paradigm you're used to, while also scaling well with advanced native type safety and very strong performance profiles, rivaling that of Go, C#, and Java. In this post, we'll explore 5 reasons F# is a great Python alternative and why you might want to try it for your next ad hoc script, side project, or large enterprise app. The first reason is low boilerplate. So people often choose Python because its syntax is very minimal and clean. It's very easy to pick up a Python program, read it, and understand what it's doing. In fact, a lot of people kind of talk about Python as if it's cheating, like it's pseudocode. It's almost just like English with a few more syntactical rules. And a lot of this is due to its minimal syntax, but also its bias towards low boilerplate. Python programs are usually very to the point and don't have the dozens of layers of abstraction that's common in more enterprisey apps. And it's interesting that some of this is due to minimal syntax, but I do think some of this is also just due to the backgrounds and the kind of context, the styles of these languages. Like Python is very Pythonic, if you will, which kind of tries to go towards like very simple, even if that simplicity is a little bit magical, versus kind of like when we think of Java or often even C#, we think of these like abstraction layers of a factory for a builder, for a thing, for an interface kind of thing. And so a lot of this is due to minimal syntax, but a lot of this is also due to styles that are enabled by the kind of paradigm of the language. And so I'm going to provide some very contrived, simple examples, but to just kind of give you an idea of Python versus F#. And so here's an example of a Python function. This is pulled via Python to F#, and this one is untyped, obviously. It's just give me the length. So you give it an input, presumably this is a string, and then we take the length of this, or this might be a list too, I guess, len is for list, and then it just returns this. Now F# is similarly low boilerplate because it's focusing on these simple data structures, as pure functions, has list operations, and also it has this very simple like no bracket kind of, and so it should look pretty familiar. And so here's that same thing in F#. You say give me the length, it can take an input. We're creating a variable here. We're saying, hey, give me the length of that, and then we're going to return the result. And you can see that we can do this, in the same way in F# without types. But the cool thing, the super cool thing about F# is that actually this is typed, and so it will throw errors. Even though I have no types here, it's going to throw errors if I can't do this. And so it's able to do this kind of inference of types so that you can write it just as simply as you could in Python, but you actually get much more safety out of it, which we'll talk about later. But basically what this allows you to do is get much more power for much less input boilerplate or overhead or verbosity because it's just built in natively. There's a bunch more examples here. This is a great little GitHub repo comparing Python, F#, and how you do things, the same things in both. So if you're trying to look for more examples, I'd recommend looking at this. Okay, the next reason is that it has a very large ecosystem. So another reason people choose Python is it's a very large ecosystem, particularly for building web apps and data ML operations. Really for data ML operations, Python is really not rivaled by anything. It's kind of the standout leader. But it also has a really good web app community, especially with Django, which is used heavily in many, many different companies. And the reason it got so good, the reason it got so big is because this ecosystem has been built up over decades of Python being a top 10 language in the industry. And obviously when you have so much popularity, people are going to be building more technologies, they're going to be improving the technologies. And so over a decade of being a top 10 language, you're just going to get a lot of really good battle-hardened choices for libraries and tech. Now in comparison, F# is pretty small. F# ranks 37th in the world in terms of usage and thus has a comparatively small ecosystem. And this kind of scares a lot of people away from F# because they're like, I'm going to have to reinvent the wheel here. There's not going to be any support. I'm not going to be able to do anything. But what a lot of people don't realize is that F# runs on .NET and thus can leverage libraries targeting .NET. And this basically means it can use anything written in C#, which itself is a top 10 language. So yes, F# is not a top 10 language. It is not going to have the most libraries in F#, but because it can use C#, it basically has the power of a top 10 language in terms of the battle-hardened libraries, technologies, and choices you can get from a large ecosystem. And so F# may not be able to beat out Python for data operations. And let's be real, there's very few things that can beat out Python for data operations because it has that decade of top 10 really focused on doing that data stuff. But it has a huge advantage in the world of scalable enterprise web apps due to decades of investment from Microsoft and the C# community. And C# really has, when you think about enterprise development, it's really like, C#, Java are the web-based behemoths. And F# gets all of that decades of being top 10 in that and can leverage it itself, thus kind of making it a top 10 for these kind of web-based projects, especially at scale, high load, stuff like that. All right, the next thing to choose F# for is that it is fast. So F# runs on .NET, and .NET is very fast. From like the Java land, this is kind of like Java runs on the JVM, and it's like also Kotlin, Scala, Clojure, etc. targets JVM. F# the same, targets .NET, and so it gets a lot of its power and performance profiles from that runtime, which is .NET. Now, in comparison, Python is pretty slow. A lot of people fight me on Python slow, but like if you compare it to literally most languages, it's slow. So we should just accept that Python's a slow language. Now, for most apps, performance is rarely the bottleneck. But if performance does become the bottleneck, which it can do at scale or for certain workloads that are very compute intensive, it can be very hard to fix this without a major rewrite of your app. There's basically a speed limit on some tech stacks, so you're going to have to figure out ways to work around the speed limit, usually with like vertical, horizontal scaling, etc., or just a complete rewrite, re-architecture to avoid the bottleneck. Now, choosing a faster technology at the outset can help ensure you don't run into these costly problems later on. If your speed limit's just higher, then you've got much more room to play with before you have to do the expensive rewrite. And so for some high-level data, kind of comparing F# to Python, F# is just as fast as C#, which rivals Java, Golang, and Kotlin, which are also considered very fast. Now, Python is typically 2 to 5 times slower depending on the workload, and which makes it closer to Ruby, JavaScript, and Elixir. Now, I want to caveat all this that all benchmarks have asterisks. Performance is highly dependent on the workload, the actual implementation you use, and the goals of the application you're building. Like if your workload is not performance intensive, then like, who cares? So take all of this with a grain of salt. For the numbers I'm pulling after this, I'm pulling the results for about the most popular framework, like the one an average person might choose, and a result that looks reasonable to try and avoid outliers because benchmarks are notorious for having people coming in and doing crazy things that you would never do in production just to game the numbers. And so this is my way of trying to pull out an average number. But, this is very subjective. It really depends on a lot of use cases. So, take this all with a grain of salt. Okay, and so, to back up some of these numbers, here are some of these technologies from Web Frameworks Benchmark, which is basically just a simple web framework that is going to return dynamic data. And this is like how many requests per minute that it's returning. It might be requests per second, something like that. Anyway, higher is better for this. And we can kind of see that, F# is kind of in this group, although Kotlin is like underperforming in this benchmark for whatever reason. So really it's in this group, right? It's like the 100 to 180. Java is performing very well. But we can kind of see C#, F#, Go, Java are kind of in the same bucket, and Kotlin is usually up there as well, but it's just performing badly. And then we can kind of look here and we kind of see that like, okay, Python is like quite a bit slower, like 10x slower. If we look at that, it's down there with Ruby, and then Elixir and JavaScript are in this bucket, although they're also doing better than Python. Another benchmark that I like to use is Tech and Power benchmarks for fortunes. Kind of checks both the requests at the request level, but also how it handles kind of database activity as well. And again, we can kind of see like F# is in this bucket with Java, Kotlin, C#, Golang, and then Python is in the slower group with JavaScript, Elixir, and Ruby. And so these numbers are basically meaningless because, your own tech stacks can be different. As a whole, an aggregate, we can kind of use them to understand comparatively where each of these technologies lie in their performance profiles. Okay, the next thing that F# has going for it is that it's type safe. So one of the major problems with Python is that it's just not very type safe. And yes, recent versions have started allowing for type checking, but the truth is much of this is kind of bolted or taped on, which means that it's going to have a finicky lint setup that often misses things, and it has an inability to do strong advanced type checks at build time. And again, I think I'm probably get a lot of pushback on this, but let's be real, Python's type checking sucks. I've used Python, for the past like 4-ish years at many different companies, at Instagram, which is one of the largest Python deployments in the world. Now at Rippling, which is more like a startup version of this, and it just does not have good type safety. Yes, you can do different types. Yes, you can have like generics, but it's like very tedious. It's very finicky. The type checking is not all the way there. You can still push runtime issues. And so it's there, but it's not good. And so you can disagree with me on this, but if you do disagree with me on this, like go use a language that has good type safety and you'll see the difference. Why is this a problem? So this is a problem because type safety is one of the best ways to prevent common bugs and speed up development in large organizations. If you don't have type safety, you're going to shoot yourselves in the foot. You're going to be cutting wires that shouldn't be cut, and you're basically going to incur a bunch of bugs and firefighting and rework because you keep breaking yourselves because you don't have the system helping you. The system is just letting you do whatever. And honestly, that's just not good. So in comparison, F# has an excellent and native type system. And so this type system allows for things like discriminated unions, exhaustive pattern matching, and it can infer most types. What this means is that it's easy to write precise types and there's very little tedious boilerplate involved. And so again, we go back to like what we think about type systems and kind of enterprise applications. And a lot of reasons people don't like it is because it has all these abstractions and tedious boilerplate. You've got to write factories of builders of interfaces and stuff to get good types. But actually, F# is one of the newer languages that uses kind of inferred type system. And so it gives you that strong typing, but you actually don't have to declare your types very much, and often not at all. It's just going to let you know that like, hey, based on what you're telling me, this could be a problem and you need to resolve this. And what this means is that, if the compiler is accepting it, it's unlikely you're going to have any runtime type issues, but you get all of this without any of that boilerplate, without any of that overhead, which makes it very nice and easy to use. And so this excellent, easy to use type system makes F# actually a great choice for defining domain models, and thus is really excellent for domain-driven design for any skill. I would highly recommend the book here. It's the best book I've ever read on domain-driven design, and it also kind of shows you how a good technology can really make it impossible to have bad states in your program and thus save so much bugs, firefighting, rework, etc. at scale. And so I could write books on how important type safety is, but this is just a blog post. So if you're interested in more, I'd recommend the Why Use F# blog post series from F# for Fun and Profit. It really is an excellent resource, and I think will give you a better idea pretty quickly of the power of type safety. Okay, the final thing that F# has going for it is that it is still fun to use. So ultimately, most people choose Python because it gets out of their way and lets them do what they want quickly and easily. The point of technology is to aid us in our endeavors, and ultimately Python does that pretty well, at least at small scale. This idea of supporting you while getting out of the way often makes tech fun to use. You're not artificially held back by bad design decisions. It's not irritating. It's not adding extra workload for no reason. It just lets you do what you want and gets out of your way. Now where F# shines is that it's fun both at small scale and at large scale. It's fun at small scale for the same reasons Python is. It's easy to do things and it gets out of your way. It's fun at large scale because it's still easy to do those same things. The type system prevents you from shooting yourself in the foot without the complexity and bloat most of the, enterprisey OO type systems tend to incur. Next. So F# has been my favorite programming language since I found it several years ago. It takes the best parts from many different languages and tosses the parts that suck. For these reasons, I think F# makes a great replacement for Python for many different applications. If you like this post, you might also like the best way to get started learning and building with F#, why F# is a fun programming language, or build a simple F# web API with Giraffe. That's it for this video. Thanks for watching, and I'll see you in the next one.